Hello my dear students, welcome back to the St. Joseph Composite View College, Vijaypur. And now, in the present video, I just want to extend the discussion regarding the D block elements. In this video, I just strictly talk about the electronic configuration and the position of the D block elements. So the position of D block elements. Very simple part is that in the periodic table you have seen that there is 1, 2 and there is gap, and then it starts with 13 to 18. Okay, now from here, from group number 3 to the group number 12. So group number 3 to 12 is there. Now this position in the periodic table is occupied by D series elements. D series elements are there. D series elements. Now the position, if you want to talk, they are in between the 2 and 13th group. So 1 and 2 together we can call them as S block elements, S block, and 13 to 18 we call them as P block elements, and 3 to 12, whatever the groups are there, they are belongs to the D series. They exist between the S block elements and P block elements. Now the property is also very similar here. The properties of the D block elements are in between the S and P block elements, and because of that reason they are called as transition elements. Okay, now we'll list out the first point. This is the first point, that is what is the location we have to list out. Location is the D block elements present between yes, what you said here, S and P block, between S and P block elements, between S and P block elements. Okay, this is the first point, and we have to mention the numbers. The number second here, the D block elements belongs to group 3 to 12. D block elements belongs to 3 to 12th group. So there are totally 10 number of groups are there. Okay, so, and if you talk about the periods, this is our groups, the periods, and period number, the 4 to 6 period. We'll discuss that in the later case. Now these 4 to 6 periods are there. Now in between them there are totally 4 series are there, 4 D series. Let me have those here. The first one, it is 3D series, then 4D series, then 5D series, and next one is 6D series. These are the 4 series we have. 4 D series, D block elements are there. D block series, D series are there. Series. So that's in case of periods. Okay, now let's understand the electronic configuration of different elements. I strictly concentrate my discussion, or restrict my discussion, only for the 3D series. So this is for 3D series. The first element in the 3D series is scandium. The atomic number is 21. It is scandium. Electronic configuration can write, that is, let me write the first one in detail. 1s2, 2s2, 2p6. So we have 10 electrons right now. Next, so 1s2, 2s2, 2p6, 3s2, 3p6 we have. So total how many electrons we have? 18 electrons we have now. The total, there are 18 number of electrons. After 3p, we have to write here 3d. Okay, 3d, I don't want to write here 3d as it is here. Okay, 3d, and 4s is the next. Now when we fill the electrons, you can look at this 3d and 4s. Out of these two, which one have an energy lesser or greater? We have to check. We have to use here n plus L rule. Hope you remember in atomic structure. Here 4 plus 0, that's equal to 4 we get, and here 3 plus 2, that is 5 we have. According to the Apo principle, the orbitals are arranged in such a way that their energy should be increasing order. Okay, therefore the 4s we have to write first, and 3d we have to write at the last. Okay, so now the electronic configuration get changed. Get changed, and we're going to write here, it is a, yes, let me write once again, 1s2, 2s2, 2p6, 3s2, 3p6, 4s. So I don't want to write here 4s. Let me write here 3d only. 3d 4s. Now the electron fill up at the 4s first. That is 2. Remaining electrons we have to write here. So that is how many electrons? So 10, 18, 20 and 21. D1 series. Okay, it is a D1 series we have. Now why I'm writing this? So 3d is filled later and first it fills the 4s. That's the case, students. Now if I go with the next, this part I want to represent something else. So you can see that this is the electronic configuration of argon. So therefore I will write square bracket argon, then I write here 3d 1 4s 2. This is the short form of electronic configuration of D series. Let me write one more thing, that 22 is titanium. Titanium we have. The titanium having electronic configuration, that is argon. Let me write here argon. Argon, that is 18 electrons. Then 3d 2 4s 2 we have. That's the electronic configuration for titanium. Next 23. Then 23 atomic number. The element is vanadium. That is argon. 3d 3 4s 2. You can notice here something is common here. 2 3. Here it is a 2 and here it is 3, like that. So let's see the next one, 24. The 24th element is chromium. Very important. Let me write in a different way. Chromium. It needs explanation. Argon, and it is a 3d 4 and 4s 2. Now the problem is the energy difference between the 3d and the 4s is very small. Okay, let me write that point. Energy difference is very small, and because of that reason one of the electron get enter into 3d4 orbital, 3d, and by that what happens, the 3d get half filled. So let me write that, change the part, that we're going to write argon and it becomes 3d5 and 4s 1. So here both are half filled, they are half filled, hence they are stable, half filled, and that gets stabilized. Okay, that's an exception, you have to remember this. Next, go for the 25 is the Mn. So Mn, we can write here argon 3d5 4s 2 we're going to write. Okay, now 26 is iron, Fe, that is argon 3d 6 4s 2 we're going to write. Okay, next part is very simple, we can understand this. Okay, so let's 27 is nothing but cobalt, capital C and small o. You are right, don't write that small c or capital O or something, don't mess up with these symbols. The argon, and is at 27, therefore I will write 3d7 I'm going to write here, and here is 4s2. There's no change in that. Now the 28 is nickel, capital N and small I, then again argon I will write, and then this is a 3d8. again you can see that the common term is coming here, 4s2. 29 again it is an important, there is an exception, that is copper. So we can write the copper electron configuration argon 3d9 and 4s1. Again we can give a same kind of explanation here. The energy difference between 3d and 4s is very small. The energy difference is small. Energy difference is very small, and hence because of that reason one of the electron jumps from, okay, it should be 2, right? So let me write here, it should 2. So one of the electron jump from the 4s to 3d9. Okay, so 4s electron jump, it get jump, let me write it, jump to 3d, and we get a new configuration, that is argon we have, and it is 3d10, we get d10 configuration and 4s1. Now in this case the d orbital is filled, completely filled. D is completely filled, and S is half filled. Okay, this is a half filled, and therefore so this leads to the stability. Now it is stable configuration we got. Now next one, that is 30th element, that is zinc. We have here argon, then 3d, then 4s2. So this is how we're going to write the electronic configuration of various elements. Okay. So we provide why the chromium and copper have different in the electronic configurations. Okay. Not only this, we'll see some more general electronic configurations of all 4D series. General electronic configuration. General electronic configuration for 3D series. 3D series we can write here. That is argon. That is 3D that varies from 1 to 10 electrons, and the 4s should have 1 to 2 electrons. You can see in that examples just what I explained. Okay, then next one is 4D series. In that we're going to use Krypton. Krypton is the that you can say noble gas, and then it is 4D 1 to 10, and it is the next, the 5s, that's having 1 to 2. And after that we have 5D series. These electronic configurations are needed, students. Then we have here xenon Xe, and here we have 4f. That should be definitely, there is no variation, there is 100%, there is 14 electrons should be filled. The f orbital is completely filled here. And next 5D 1 to 10 you get. Okay, and then 4s is that is completely filled. There is no 1 to 2. You remember, this is an exception. Okay, so it is somewhat changed here, right? Next 6D series. In the 6D series you can see that we have the noble gas, that is radon, Rn it is. Then 6D I will write here 5f will be there, but let me write here 6D 5f. Let me write 5f first. 5f 14, and then 6D 1 to 10, and 7s 2 will be the electron configuration. These electron configurations you have to remember, students, because this is the most important part. Now let's go to the one more discussion, that is electronic configuration of copper and chromium. That we have to go into. This is a burning you can say that discussion. Information is very important. Electronic configuration of chromium and copper. Electronic configuration of chromium and copper we're going to discuss. The first thing, the general electron configuration I'm going to write for the chromium and copper. For the chromium, what I'm going to write here, chromium, that is equals to argon, and here this is 3D5 will be there, and here it is a 4s1. This is one type of electronic configuration. And copper also we can write the copper having argon and 3D10 and 4s1 we have. So these are very special kind of electron configuration. Many times in the examination they have asked. We have to use n plus L rule here. Okay, the energy difference between the 3D and 4s orbital is very low. This is the first point. Explanation it is, we have to write the energy difference between that is 3D and 4s is very small. It is very small, as I mentioned. So even I done the calculation, right? So n plus L rule we have to use to explain the energy difference. Next, second point is that the d orbital being degenerate. D orbital, this is very important. D orbital being degenerate. What is the meaning of degenerate? So degenerate means having same energy. Degenerate means same energy. All the orbitals, d subshell having 5 orbitals, and all the 5 orbitals have same energy. Okay, they acquire more stability. The degenerate is, they acquire more stability when they are half filled or completely filled. When they are half filled, this is important, half filled or completely filled, Okay, these are the two important things, students. One is d orbitals being degenerate. They are degenerative because all the dxy, dy, dzx, dx square minus y square and dz, all the orbitals have same energy. Okay, and they are become more stable when they are half filled or completely filled. Okay, this is one. And there is one more still we can write. The third reason we can write. The third reason is the because of 1 and 2 reasons, the electron from the transfer of one electron from transfer of one electron, let me write one electron from 4s to 3d orbital, 4s to 3d orbital in chromium, giving more stable half-filled orbital, giving more stable half-filled configuration. Hope you understood this part, students. Okay, the same thing you can write for the d block, that is copper, where you can write here, so one electron jumps from the 4s to 3d, the orbital giving more stable completely filled configuration. Okay, hope you understood. In examination you have to write all these 3 points. Energy difference between the 3d and 4s is very small. D orbital being degenerative, they acquire more stability when they are at half filled or completely filled. The transfer of one electron from 4s to 3d orbital giving more stable half filled configuration. Okay, now this is all about the general you can say that electron configuration of d block elements. In the next video I'm going to discuss the general characteristic of transition elements. Thank you for watching, students.